So we're going to try this out. I hope this works. This is new software that I haven't used, and I'm trying to make it work with my smartboard software from my home computer. So I hope you can see this. This is the identifying displacement and velocity profiles. Again, as I explained in class, we're going to kind of pretend that all of these are, for the first part, displacement profiles, and for the second part, velocity profiles. So that's kind of the plan. I don't know why that moved. I'm going to try and make that unmove. I guess. I don't know why it's there, but it moved. Okay, well, whatever. So the first one, the object is standing still. For a position time profile, so we're going to use this as position time, we're going to need a flat line where it's not moving. So that would be letter A. That's going to be letter D. And that's also going to be letter F. Okay? Because those are where, when the object is standing still, the velocity is 0, which means the slope is 0. So any flat line here. 2, the object has a constant positive velocity. So that would be a positive slope because, again, the slope gives us velocity. So that's only going to be letter C. 3, the object has a constant negative velocity. There are actually 2. We're looking for a negative slope. So letter B has a negative slope. See it there. And also letter E has a negative slope. So again, we're using displacement versus time, and you're dealing with something that has a negative slope. Finally, the object reverses direction. Those are going to be both G and H, because we're dealing with something with a position. It's going in the positive direction and then in the negative direction for G, and then for H in the negative direction and then in the positive direction. So I hope that helps you out a little bit. Get this out of the way. And now we're going to switch gears. We're going to turn this into a velocity profile, where this is velocity versus time now. So I'm just going to make a little note for myself as opposed to displacement versus time. All of these are going to be velocities. And we only know one velocity, and that's where the velocity is actually hitting the x-axis, and that velocity is going to be 0. So the object is standing still. That is where the velocity is A at 0. The object has a constant positive velocity. That is going to be letter C because, oh, I'm sorry, not letter C. That object is going to be letter D because we're dealing with a constant velocity, so a straight flat line in the positive area. So that's letter D. The object has a constant negative velocity. That should be letter F because we're dealing with a flat straight line, no slope, constant negative velocities there. The object reverses direction. That is actually, let me erase some of my markings here. That is, as we talked about in class today, right here at letter E. Because this is an object that is, at this point, going in the positive direction because it's a positive velocity. And here it's going in the negative direction, so negative velocity. And in between the two, as we talked about, you are going to have a stop. So that's letter E, the reversing direction of the object. Number 9, the object speeds up at a steady rate and then slows down at a steady rate. That is going to be letter G, because you're dealing with the object speeding up, getting further away from 0, and then slowing down, getting closer to 0. And finally, the object slows down at a steady rate, then speeds up at a steady rate. I'm going to say that is letter H, because we are dealing with a positive velocity that is getting slower and slower and slower and eventually stopping, and then speeding up over here. We're also talking about letter E because the object is slowing down, and then ultimately stopping and then speeding up in the opposite direction. So I hope that helps a little bit, and there you go for that. I hope you learned a little bit of something. Let's see if this actually worked.